Okay, 1.5b, which is part 2 of linear inequalities. First section, we were just doing some simple inequalities. Well, they're not simple, but they're called simple inequalities. The back to this is, and I'm going to use a fresh sheet because that one, you can see all my highlights through it. The fresh sheet shows us the compound inequalities. These are called compound because there are more than one inequality. Even though it doesn't look like it, there are two inequalities in these statements. And let me show you what I mean. When I'm looking at and inequalities, these are the most restrictive inequalities in which they have to, the solution has to answer both inequalities. Now, what I meant was, you're probably looking at this saying, well, there's only one inequality statement. Yes, but and this is a good acronym for this because it says they're sandwiched. This is actually two inequalities. Okay, if I were to expand this, these two inequalities would be negative 2 is less than the quantity 3t minus 8, and 3t minus 8 is less than or equal to 10. There's my two inequality statements. Now, we can actually shorten up and statements by squeezing them together because this is the same number. So we could actually just put one of these in there, and just what it does is it kind of eliminates the and the 3t minus 8, one of the 3t's minus 8s. Can only do this with and statements. Okay? And means that the solution has to satisfy this inequality and this inequality. So when you see this sandwiched inequality statement, it's actually two inequality statements. So we're going to go ahead and solve for t. And again, keep in the back of your head and back of your mind that this is actually two inequality statements. So not only are we going to have to worry about doing it, solving for t from one side of the equation to the other, it's actually inequality, but for the second one as well. Okay, so let's go ahead and start solving for t. There's my t, but I'm going to have to get this t term by itself first. So I'm going to undo the minus 8. I'm going to add 8. Now, whatever I do to one side of the equation, I got to do it to the other side of the equation. So I'm going to add 8 over here. And don't forget, I'm working with two of them. So if I add 8 to this, I have to add 8 to this inequality also. Oops, there should be a plus on. Okay. So I've got negative 2 plus 8 is positive 6. I did not multiply and divide by a negative number. So I'm going to actually see if I can zoom in a little more. So I'm going to keep my sign the same. These add up to 0. Don't need to put a 0 there because I'm bringing down my 3t. Again, keeping the sign the same. 10 plus 8 is 18. Now these The reason why this is an and statement, I should have mentioned this earlier. And statements are less than or equal to sign. Now I still have to get that t by itself. Okay. And it has a coefficient of 3. So I'm going to divide my 3t by the coefficient 3. Whatever I do to this side of the inequality, I have to do to this side of the inequality, and I have to do to this side of the inequality. So my t 3's cancel. I'm left with my t, and 6 divided by 3 is 2. I divided by a positive number, so my inequality sign stays the same. 18 divided by 3 is 6, stays the same. So here's my solution. 2 is less than or equal to t is less than or equal to 6. Now, this is an and statement. It's sandwiched together. So my graph is always going to be one of those in-between graphs. Either bracket or parenthesis, and I'm going to shade in between. Always going to be true for my and graph. So I'm going to go ahead, put my graph down here. It's in between 2 and 6. There's my 2. There's my 6. It's in between. And since this has a negative equal sign, it's a bracket. It includes 2, and it also includes the 6 because of that equal sign. And for interval notation, for and statements or and inequality statements, it's usually just the one interval here. So I have 2, 6, bracket. I got bracket, 2, 6, bracket. Okay, let's do number 7. See, I'm going to have 2 inequality problems. Have to get this one's an x, have to get that x by itself. So I'm going to add 3 to this side, add 3 to this side, add 3 to this side, because there's 2 inequality statements there. That gives me negative 12 plus 3 is negative 9. I'm adding, so keep all the signs the same. 3x, 15 plus 3 is 18. Divide by the coefficient 3. Got to do it to this side. Have to do it to this side. Divided by a positive number. Even though that's a negative number, I'm dividing by a positive number. So I'm going to keep that sign the same. Negative 9 divided by 3, negative 3. My x, 18 divided by 3 is 6. So my solution, negative 3 less than or equal to x is less than 6. Graph it. Here's my negative 3. Here's my 6. It's in between. Shading in between. My negative 3 has an equal sign, so it gets a bracket. My 6 does not have an equal sign, so it gets a parenthesis. Interval notation, bracket, -3, 6, parentheses. Okay, so that's the and statement. Now, the or statement. Somebody came up with ors on a boat, non-restrictive, which means it can be, this is where your two inequality statements go opposite ways. So you're either going to have a parenthesis or bracket going out to positive infinity, and a parenthesis and a bracket or bracket going out to negative infinity. And of course, with the symbolization, when you put it in interval notation, it's a union. So either this or this. That's why we call it a non-restrictive. Now, there's a but to this one. Okay. Sometimes we can have one of these ors, so to speak, overlap. Say it goes from here and out to negative infinity, in which case that would include all real numbers. Once in a while, this will happen. So it's one of those mathematical exception things. By the way, the symbolization for all reals is a double bar R. So if you see me write double bar R, that means all real numbers. It's just symbolization that I'm used to using. Okay, so and or statements are greater than or equal to. So when you see those symbols, it's an or problem. Or oars on a boat. That's where they came up with oars on a boat. Look like oars. All right, so number 4. It's an or problem. So my graph is going to look 99% of the time like this. And I have to solve each one of these inequality statements. Now, these you can't sandwich together or squish together. You have to solve them separately, even if it's the same number. Okay. All right. So I got to get rid of, for this inequality statement, I have to get rid of this constant. Remember, I want variables on one side, constants on the other. So I'm going to subtract 3 from both sides. And I get 2x. I'm subtracting, so the sign stays the same. 5 minus 3 is 2. Divide by the coefficient, 2. And for this side, I get x is less than, I'm dividing by positive, that stays the same, less than 1. Or, go ahead and solve this side, plus 7, I get 4x greater than 16, divide by 4, I get x is greater than 4. So that's my answer. That's my solution. That's my inequality statement. X is less than 1, or x is greater than 4. My graph, I know it's going to look like boat oars. Let's see, I need a 1, and I need a 4. Let's see, no equal signs anywhere. So they're going to be parentheses. This way towards negative infinity, out this way towards positive infinity. Interval notation. smallest number, negative infinity, next smallest number, 1 gets the parenthesis. We join these with a union symbol, parenthesis, 4, and then positive infinity, parentheses. And the last one, number 5. Now, I'm looking at this, it's got a couple of stars here, so there might be something going on. It might be this whole all real numbers thing. Okay, could be. Something's going to happen here. So here's my 2 inequality statements that I have to solve individually because it's an OR statement. Let's see, I'm going to subtract 7. I have negative 2x less than or equal to negative 4. I'm going to divide by negative 2. Maybe this is the star thing. Because I divided by a negative number, I have to flip my inequality sign. Negative 4 divided by negative 2 is positive 2. Subtract 5. Subtract 5. I get negative 2, or I'm sorry, positive 2x is less than 10. Divide by 2. Divide by 2. I get x is less than 5. So here's my solution. X greater than or equal to 2, or x is less than 5. My graph, let's see, I need 2 and I need 5. Okay, x is greater than 2. So actually, it's not going that way. It's going this way. There's the stars. So that's going that way. And this one, x is less than 5. Oh, by the way, that gets a bracket, right? X is less than 5. So this time is going out that way. Boy, this one's really got some different things going on here. Parenthesis. If you look at my shaded area here, it's all real numbers, isn't it? I can just do this for my interval. All real numbers, or if they're being specific, yeah, you would have to put the whole thing here. But this is the answer, all real numbers. And that's it for 1.5b.